Cinematic VR Crash Course.
Welcome back to Lesson 2 of the Cinematic VR Crash Course, in which I will guide you through the various type of 360 camera rigs that are currently available, so that you will be able to pick the rig that suits your needs best. Let's dive right in. There are quite a few 360 cams already available, and new products and Kickstarter campaigns seem to be launched on a weekly basis. However, they can all be categorized into a couple of broad categories. 360 2D, which is the simplest form of 360 video. Stereoscopic 3D, which uses one lens per eye. Algorithmic 3D, this uses computational photography algorithms to calculate the 3D effect and minimize parallax, an important term which we will cover in more detail later on and which you can also find in the glossary, which is part of this course. And LIGHTFIELD and 6DoF. These cameras do not only capture images but also scan the environment to recreate the room as a photorealistic 3D model in which you can actually move around. The first question you should ask yourself is, what quality am I after? Let's quickly go through each of the 4 categories of 360 camera rigs to see what your options are. 360 2D. If your plan is to simply film 360 videos, you have a broad selection of cams to choose from. I'll keep it brief. You can choose a camera that automatically outputs a full panorama video, like the Ricoh Theta, 360 Fly, Insta360 One, or the Samsung Gear 360, which makes producing 360 videos a breeze. These are consumer cameras and the quality of these low-budget cameras really improved over the years. Depending on what you use, there can still be some limitations, like low resolution, no low light capabilities, limited compatibility with other devices, or poor software tools. The other option is to go for a more professional and modular 360 cam, like the GoPro Omni rig, or the Z-Cam S1, which will give you several individual video files, which you then have to stitch together into a panorama video yourself. The image quality of these rigs can be much higher, but so is the price. We'll cover stitching in detail in another lesson. For now, it suffices to know that stitching is the process of combining individual video files into a single seamless panorama. As mentioned before, you need to add 3D to your 360 videos if your goal is to shoot immersive cinematic VR experiences. One way to achieve this is by using a stereoscopic camera rig. What is stereoscopic 3D, you're asking? According to the brilliant folks over at the Foundry, stereoscopic 3D is an attempt to reproduce the process by which we see with our own eyes in order to produce a feeling of depth. You can create a stereoscopic 3D image by filming an object from slightly different angles, using 2 cameras separated at the same distance as your eyes are. This distance is called the interpupillary distance and is on average 64 mm. When viewing this image in a VR headset, your left eye sees the left image and your right eye sees the right image. Your brain then creates an illusion of depth. A 360 3D rig places such stereo pairs all around. One of the first available options was a GoPro rig, like the 360 Heroes GoPro mount, which is now called 360 Rise. You get a 3D printed mount, which holds between 12 and 14 GoPros, depending on the model you choose. These rigs work, however their build quality is not amazing. The major limitation of this rig is actually not the mount itself, but the GoPros. GoPros easily overheat if you're shooting cinematic VR content. Because VR requires high-resolution, high-frame-rate images, also the cams quickly run out of power, especially if you have Wi-Fi turned on, which you will because you'll need a GoPro Wi-Fi remote to turn all 14 cams on at the same time. On top of that, taking 14 SD cards out one by one to transfer your footage to your editing station is quite labor-intensive. With our Purple Pill camera, we try to solve all of these issues. The rig can be outfitted with heat management technology to prevent overheating, and has the ability to power the entire rig for extended filming. Has a 1 cable readout of all the video data, as well as an ambisonic microphone to record realistic spatial audio. This camera used to be a great solution, because you simply couldn't buy a camera which shot stereo 360 in 2014. This workflow with 16 GoPros is simply not efficient anymore, since there are other one-stop shop camera solutions. It took us months to design and develop this camera rig though, and we're still very proud of the result we achieved with it. We gave it a permanent spot in our office, where it can rest in peace now. If you're still interested in building such a camera, go ahead and take a look at purplepill.io/camera. For exceptional high-resolution capture, you can also consider building a custom cinema camera rig, like this stereo red dragon rig. You do have to have quite a budget for such a rig though. So, stereoscopic 3D is pretty cool, but the biggest limitation of 360 videos, and in particular stereoscopic 3D, is something called parallax. Imagine the following simplified scene with one object and one camera in it. If we move the camera slightly to the right, the object will seem to move in relation to the background. This apparent change in position of the object is called parallax. These are the resulting images. If we want to stitch the images of these two cameras together, we can either align the object or we can align the background. We cannot do both. This is why parallax can result in ugly stitching errors, and the closer the object gets to the camera, the bigger this parallax effect will be. The only way to get zero parallax is to have all the camera lenses, and therefore the focal point, positioned dead center in the rig. Since this is physically impossible, the only way to achieve this is by using sophisticated software algorithms. Over the years, these algorithms have become better and widely available for professionals, starting with the GoPro Odyssey, which was a part of the Google Jump project. This camera is based on 16 individual GoPros and again a 3D printed model, but includes automatic synchronization and data handling. The downside is that this camera will leave you with a black spot, both up and down. Its successor, the eHalo, does have top and bottom cameras and is known for its great workflow. The award-winning Jaunt 1 is the first professional-grade camera system specifically designed for capturing high-quality, high frame rate, high dynamic range, stereoscopic, cinematic VR experiences. But with quality also comes a price tag, so do know that using their camera and algorithm is expensive. The Nokia Ozo has probably the most beautiful design and also features live preview, interchangeable digital cartridges, global shutter and weighing in under 10 pounds. Nokia also provides really good software tools to use in the Ozo workflow. The Ozo doesn't record full 360 stereo images. 140 degrees of the image is in stereo. Unfortunately, Nokia announced that the development of the Ozo camera has been discontinued. Much cheaper options are the Chinese 360 camera brands, Insta360 and Kandao. These cameras also deliver high frame rate and high resolution images with built-in live streaming. This is truly amazing for the price and makes them very popular for prosumers and professionals. They do differ a bit from the others though, either in build quality, provided software or additional hardware you need to buy. Finally, the Zcam V1 Pro, which has close lens positions, high quality lenses and sensors, a very promising camera. All these cameras have their own stitching software, but it's perfectly possible to stitch these images with third-party software, which we will discuss later in the course. And if you're not confused enough already by these three options, there's another one, LIGHTFIELD or 6DoF capture. I'll just go through this quickly because this will probably take a while to become available for the masses. First, you'll need to understand the concept of 6DoF. As a viewer of a normal VR video, I'm limited in my movements. I can only make rotational movements with my head. This is called 3DoF and lets you pitch, jaw and roll your head. With 6DoF, you'll be able to move over the three other axes. These are the translational axes: forward, backward, up, down, left, right. In order to experience a video in which I'm able to move over these translational axes, we also need spatial information. With LIGHTFIELD technology, you'll be able to scan the environment either by laser technology or by recreating the room through videogrammetry. In this way, we can create a 3D model with photorealistic textures to enable the viewer to literally move through a video. Because 6DoF combines computer-generated and live-action imagery in real time, it has to be played back in a game engine. This opens up loads of different options, like relighting the scene or creating a different depth of field. Just like 360 video once did, 6DoF unlocks new dimensions in storytelling and will push filmmakers into uncharted territory. Lytro is on the forefront of LIGHTFIELD capturing. Their Emerge camera is the world's first solution for capturing 6DoF. It uses multiple arrays of LIGHTFIELD cameras, which are processed in an internal server. It then combines the live action images with CG to blend into a whole different experience of presence. The amount of data coming from this immense rig is extraordinary. Make sure to check out their Hallelujah video, which you'll find in the list of resources. Facebook also launched their new range of 360 cameras in 2017. The X24 is able to capture full RGB and depth to create lifelike 6DoF point clouds. So now you should have a better idea of what cinematic VR gear is currently available, and what the benefits and limitations of some of them are. There is no best way, it all depends on what your goal and budget is. So take a look at the list of resources which is part of this lesson for info on where to go to get your gear of choice, including tips for microphones, SD cards, software and other useful accessories. To summarize, 360 cameras can be categorized into 4 broad categories. 360 2D is the simplest form of 360 video. There are many cameras available that allow you to easily film flat 360 content. 360 stereoscopic 3D cameras use one camera per eye to create an illusion of depth. Parallax is the apparent movement of an object in relation to the background when viewed from a different angle. Parallax is a big issue for 360 video, especially for stereoscopic rigs in which the cameras are even further apart in the rig. This can cause serious stitching issues. The only way to avoid parallax is to place all cameras in the dead center of the rig. Using advanced computational photography algorithms to create a virtual camera rig is the best way to achieve this. LIGHTFIELD technology enables a new dimension of filmmaking, 6 degrees of freedom. 6 degrees of freedom lets you move over all the 6 axes available. A lot of 360 cameras are available on the market at the moment, so put some time in researching the differences and choose the one which suits your production best. Okay, that's enough talking for now. In the next lesson you're getting hands-on as we cover how to prepare yourself for a shoot and where to base your decisions on.